Hi everyone, welcome back to my channel and today we are discussing about naive Bayes classification. So, naive Bayes classification is popular and efficient machine learning algorithm for classification task. It is based on applying Bayes theorem to make prediction, making it a powerful tool for understanding complex data relationship. Probability and Bayes theorem. So, probability basics, naive Bayes relies on understanding basic probability concepts such as conditional probability and Bayes theorem. Bayes theorem provides a way to calculate the conditional probability of an event, giving prior knowledge of the condition that might be related to that event. Applying naive Bayes classification, so independence assumption, the training of model that the algorithm learns the probability distribution of each feature given the class labels during the training phase and making prediction to classify a new instance. Naive Bayes calculates the probability of each class and selects the one with the highest probability. Advantages of naive Bayes classification. So, it is simple, fast, requires little training data, and can efficiently handle high dimensional data and works well with text classification. Whereas it has also some limitations, that is, it features independence assumption that may not always hold true in real world data sets, and naive Bayes can perform poorly when features are highly correlated. This was about the theory content. Now let's move to our coding part. Okay, guys, so let's get started. Uh, So let's take a quick look at the Bayes theorem, which is the heart of this algorithm. So it is written as P of C by X is equals to P of X by C multiplied by probably P of C upon P of X. So where P of C by X is the posterior probability, that is the probability of class C given by the data X, and then there is P of x by c, that is likelihood of x given by class C, and P of c is the prior probability of class C, and P of x is the evidence, that is a normalizing constant. So, in simple terms, Bayes theorem help us to upgrade our beliefs about the probability of our class when a new data is observed. Now, naive Bayes comes in three main flavors depending upon the type of data. Firstly, we have Gaussian naive Bayes, assumes data follows a Gaussian, that is a normal distribution, and it is perfect for continuous data. Secondly, we have multi-nominal naive Bayes, which is great for text classification problems where data is represented as counts or frequencies. Next on, we have Bernoulli's naive Bayes, that is used for binary features like true, false, or yes, no type of data. So now we'll focus on Gaussian naive Bayes and demonstrate it using the famous iris dataset. So here will use Python and some key libraries like NumPy, Pandas, Scikit-learn, and let's go step by step. So here firstly we have imported the libraries that we need to handle the data and split it into the training and test set, and then build our own naive Bayes model. Now, step two, by loading the data set. So here, Iris data set is a classic data set which features it has features like petal length and sepal width, which we use to classify three species of flowers, that is setosa, versicolor, and virginica. So here we have loaded this, and the features are loaded in X variable, and Y are stored in that is labels are stored in Y variable. Now splitting the data. So we split the data into 80% training and 20% of the test to evaluate our model. Now initialize the train model. So initialize and train the model actually. So here NB model is equals to Gaussian NB, which we use, and here we initialize model and train it using the training data. Then we make the predictions, that is y pred, that is model is predicting with x test, and then evaluating the model, that is by accuracy score, and then classification report. So we calculate the accuracy and generate a classification report which shows precision, recall, and F1 score for each flower class. Now displaying the confusion matrix. So here this has been displayed. So let's run our code. Firstly, we were importing the libraries and all, and then loading the iris dataset and splitting that dataset into training and test set. It might take a bit long. So yeah, our this is our output where there are feature name and target name. Now let's run our this naive based model and its evaluation and confusion metrics. So here is the classification report where the three types of plant have given their has have their at last conclusively precision, recall, F1 score and support, and then accuracy, micro average and macro average and weighted average. And then there is our confusion matrix. So on observing the result, so accuracy indicates that the proportion of correctly classified samples out of total samples, and classification report this provides the precision, recall, F1 score for each class, and then confusion matrix display. So after running this, we have successfully got the initial. Okay, three, two, one, start. So here, after running this code, we have got a classification report and a confusion matrix. So observing the result, where the accuracy here, the accuracy indicates the proportion of correctly classified samples out of total samples, that is one. And then classification report, it provides precision, recall, and F1 score for each database, that is Setosa, versicolor, and Virginica, and accuracy, macro average, and weighted average. And then lastly we have confusion matrix that displays to show true versus predicted tables. That is true versus predicted tables. So naive based algorithm works well here despite its assumption of independence, as the feature in the iris dataset exhibit level of independence. Now that's it for today's video, guys. We saw how simple algorithm leverages probabilities to make predictions and implement it using iris dataset. If you found this video helpful, make sure to give it a thumbs up and subscribe to my channel. And let me know in the comments if you like me to cover other algorithms and dataset. Thanks for watching.